Hello and welcome once again to episode 90 of Code Completion. We're a group of iOS developers and educators hoping to share what we love most about development, Apple technology, and completing your code. My name is Dimitri and I'll be your host once again for this episode, and I'm joined today by my fellow completionist, Spencer.
Hey there.
So, during WWDC, Apple mentioned something quite surprising, that Swift was now being used directly within the Secure Enclave, which is a coprocessor, which is not necessarily running a full OS. So that was quite the revelation that they were able to bring Swift to this very different environment. So we thought we might discuss how Swift can be used outside of apps. And Spencer, this was a topic that you brought up because there's quite a few examples that you've tried already outside of apps. So, yeah.
Yeah, I mean, of course, and this is Spencer like hoisting his flag of proudly supporting Vapor. That would definitely be the one that I've used the most, where instead of Swift being on an app, iOS, macOS, whatever, it's on a server. It's running on a Linux server somewhere. Or I suppose you could, run the same thing on a Mac Mini, but most probably it's going to be, if you're hosting this on like Heroku or something, it's probably going to be running like Ubuntu or something. And so I love that Swift is open source and people have made it available and workable on non-Apple hardware so that we can take advantage of things like Swift on the server and kind of have, at least for me, the way that I view it is like, let iOS developers and macOS developers kind of branch out outside of the Apple ecosystem in a way that is friendly to them, and they don't have to learn another language. And they don't have to kind of learn all of these different paradigms that come with a different language, where when I'm writing a Vapor app, I'm using structs and I'm using classes, and it's object oriented, and it's in a way that feels very natural to me because I'm using the same language that I already know. And it's a new API, and so just like when you dive into a new framework that is first party from Apple, there's a learning curve there. But ultimately, the language itself isn't sort of a barrier to entry in order to kind of get yourself to a certain point in order to even understand what you're doing. It's more of like looking at API documentation and trying to figure out how things work, looking at examples and all that. And that, again, just lowers the barrier to entry.
Even Foundation is available, right? So, like, just basic things like opening a file, like, can be identical to the way you've done them. There are more efficient ways of doing them, because it's a very different context and you might want to do different things with those files. But if all you want is to open an image file to do something with it, heck, you can go ahead and do that. You might not have UI or NSImage available to you, though if you're on the Mac, you absolutely do, right? That's just available magically. But if you're running Swift not on a Mac as a server, but on something else, then you have to like find a different way of working with stuff. But a lot of the basics are there, like messing around with paths. Those are just URLs. Opening files, that's just loading data, right? It's very straightforward in many of those ways. So I guess let's dive into Swift on the server as like our first tentpole of all of these. And what exactly is Vapor? Like, is it something you download? Is it a package that you brew, install? Like, what's going on with that
Good. Yeah, that's a good question. It's just a Swift package, so just like you could import some random, my go-to would always be like some charting library, but now that we have Swift charts, that kind of goes out of the, that doesn't quite work anymore. But, if you were going to import some third-party library into your iOS or macOS app, you would use Swift Package Manager in this day and age, luckily, where, again, CocoaPods were a bad dream. But it's just a Swift package, and so really all it is just a bunch of Swift code that people have wrote and open source that's just on GitHub in order for you to facilitate making some server-side app that just kind of runs on a server, or again, you could just run it locally on your own Mac. And it's just a command line tool. So it's just kind of sitting there in the background, and, it's opened up a URL in order for you to access it. And then from there, Vapor lets you create like endpoints. And so you could say like, whatever your base URL is / hello world. And then you could do a number of things. You could have it be sort of like a REST API where it could just return you some JSON that you asked for. You could actually have it render out HTML for you, or do a combination of both. And so most of the time, what I'm doing with Vapor is making just like a REST API, just sort of like a backend for some iOS app. But there are people that will, build entire websites in Vapor, and there's I think I talked about this a couple episodes ago, but it's really well, I think, broken up into like, there's kind of like the Vapor core of just like the very basic fundamental kind of functionality of Vapor, but then there are kind of different packages depending on what you want to do. So if you want to have a SQLite library, or a MySQL library, or a Postgres library, they're all kind of different, databases. They're all different third-party libraries, Swift packages that you can import, but they've also got like a templating engine to let you write HTML and kind of have that interact with your actual Swift code. So yeah, it's kind of all broken up, and that's essentially what Vapor is just a command line tool with kind of, these extensions, these kind of auxiliary functionalities that you can import as well as packages in order to make a website, make a REST API, whatever you want. It's just really Swift code running on the server in kind of its most basic form, I suppose.
And I think the coolest part of Vapor just being a package, that you can either write a command line tool, which ends up being a quote-unquote server, or you can import into an iOS app and have your iOS app just run a server that other things can connect to. Like, that's entirely possible because it's, as you said, just a package. All you need to do is import it, write up a few endpoints, which if you've never heard the term endpoint before, it's kind of like making a function available via a URL. So if someone calls a URL, it's going to call your function that you associate with it. If someone calls a different URL, then it's going to default to a 404 not found function that you can specify. And Vapor takes care of all the intricacies of how HTTP works, making and managing the connection for you. All you really need to do, managing threads and stuff like that, all you really need to do is say, hey, if I'm accessed on this URL, let me know and I will do my thing and give you a response. And then that's all I need to care about. The rest is all managed for you, so long as you follow like a certain set of rules of non-blocking and things like that. But that's a lot easier now with async await, and it's surprisingly easy to just get started. So if you've ever used an API before, I highly, highly, highly recommend that you take a look at Vapor, because it allows you to write the API that you've been using, and you can potentially design it in a way that, because it's Swift, you can just share all your models between the two like source code repos, because your app might have like a struct for, I don't know, post. Say you show a list of posts, right? And you have a struct with a post. It has an ID, it has a user, it has like a message and all sorts of things. However you describe that, if it's codable, you can now share that struct between both sets of code, and then your server implementation can just go ahead and use that same exact struct. It can even import that same struct as like a Swift package, and just write it and say like, hey, I'm going to make this struct and send it to you. You don't have to worry about writing the JSON or even encoding the JSON. Like from Vapor, that's all taken care of. On your app, you have to do more work to decode it, if that makes any sense. So yeah, Vapor is pretty damn awesome.
Yeah, it's awesome. It's super cool. Again, like Dimitri said, I highly recommend checking it out. It's like he kind of already said this, but Vapor is to like, yeah, setting up connections and all that to what, an app is. You aren't managing iOS in the background. All you're doing is like, what do you want it to do when the user taps on your app, and that's it. Makes it really easy. And like Dimitri said, async
Wait.
lowered the barrier to entry. Man, I can't talk this morning. A ton, because you're not dealing with these things called event loop futures that come from Swift Neo, which I think we'll talk about here in a second, which were just an absolute pain. And now makes it very, very easy to get started. And one thing I want to mention is, like, if you have your own app that you maybe want to store some things on the server for, on a server for, like, you're using Firebase or you're using CloudKit or something, Vapor could very well be another option for you. I wouldn't necessarily say replacement. I think there's definitely a time and place, especially for like CloudKit. You get easy push notifications and stuff. So there are like pros and cons of both, but it could very well be something that you could get running up and running very quickly again, because like Dimitri said, you can basically share your model objects, and it's just a matter of like taking the JSON that you get, the codable struct, and throwing it in a database just on a server, as opposed to, in Core Data or something. Probably take you more or less the same amount of time after you sort of learn it. So super cool. And again, I will gladly be the poster boy for Vapor, because it's just something that it's most definitely the most interesting kind of like third-party library that I've ever used, and one that I'm using regularly for kind of side gigs and stuff. But it's also just like such a cool idea that you can kind of not have to rely on something crappy like Firebase in order to have persistent data outside of your own app on a server somewhere. So it's good stuff. Definitely 10 of 10 would recommend.
And I do want to also point out, like, if you are using Vapor to write a serious app, you're going to need to use a database of some sort, like Postgres or MongoDB. But you don't necessarily need to be an expert in those databases. Like, this can be your gateway to using those different kinds of databases, especially if you've never used them before. Because totally. Vapor makes it very easy through an abstraction called Fluent to tie model objects directly to database objects. So that way you don't necessarily need to be writing queries by hand in order to access stuff. You just use the API that's provided via that library, and things generally would just work. So I think there's a Postgres Fluent library. There's like MongoKitten, which is one for MongoDB. And there's like a variety of these different implementations that all kind of work similarly. And I don't want to say that they're like hot swappable or anything, because they definitely are not. The code will need to change between them. But they do offer similar abstractions, so you can try out multiple different ones to kind of see which one works best for your app and which one works best for you in terms of like understanding everything that's going on. So definitely something to try out there when it comes to Vapor.
Yep, for sure.
And as Spencer mentioned, like Vapor and like these database libraries, all of them are based on like a common foundation called Swift Neo. And this stands for I think it's non-blocking IO, not network IO, but non-blocking IO, because it basically needed to be conceived in a world where there wasn't Swift async await yet. So it came up with an API that allows you access to a thread pool that will automatically manage itself. All you needed to do is chain a sequence of asynchronous events that would happen from input all the way to output. So if it told you, hey, you have an input and it has this data, you decide what to do with that data. And then when you're done, you pass it to the next thing that's responsible. And that goes all the way to the output, which will send it back to wherever it came from, basically. So you can set up all sorts of things like channels where like you can configure these inputs and outputs. all the way down to not needing to deal with it at all, like in Vapor's case, where you just get a request and you give back a response. Now, Swift Neo uses a very different paradigm, right, of promises and futures. And we thankfully are moving away from that. And I think they targeted Swift 6 as like the big changeover where they're rewriting the API to not use promises and futures at all anymore, and then only use async await in the most optimal way possible. Is that correct?
As far as I know, yeah. I follow Vapor a lot more closely than I do sort of like the base libraries like Swift Neo, but I believe so, yeah.
So if you ever wanted to write something more complex, like an open TCP or UDP connection, and you needed to like directly manage all that yourself, like Swift Neo is the thing to use. It's highly performant. It is highly optimized, and it is absolutely used in like mission critical server applications. So definitely take a look at that if that's something you're interested in. Once again, that's something you can use in your macOS or iOS app as well, if you did want to start accepting sockets and things like that. On Apple's platforms, it is backed by Network Framework, which is like Apple's high performance implementation of TCP and UDP. So you can go ahead and use that locally via the same API that you would use on your server, which may be running on Linux, right? Which would be very, very different than what you're necessarily used to. So you don't need to deal with pipes and sockets and threads. It's all just taken care of and abstracted for you, which is what's really nice about Swift Neo.
Yeah, I remember reading this, and I just pulled up the repository, and I can't quite find it as I'm looking at it, but I'm going to kind of paraphrase here, but I think one of the kind of biggest aims of Swift Neo was to make it kind of inherently support very well highly multi-threaded things. For example, going back to Vapor, where you could have thousands or tens of thousands of clients kind of hitting that sort of framework at the same time through a Vapor app or whatever, it can very efficiently manage, handling all of those requests to whatever it is, like Dimitri was saying, Postgres or whatever it is. That's kind of that intermediary layer between the database and the rest of the code. It's very much written in a way that can be efficient at that. So that's kind of the goal, I suppose, of Swift Neo, is to interface well in those kind of situations as well.
Mm-hmm.
Or
and it's doing that because, and it achieves that because it tries not to have things jump between threads, and it tries to keep an event that came in on the same thread all the way through, but to not consume that thread. So if a request is coming in and it's currently coming in and you need to wait for it to come in to do something with it, your block is going to be run on that thread, but you're not going to be notified until like everything actually came in. And if it's waiting on the sender to still send stuff, it's going to potentially schedule other stuff on that thread in the meantime. So it very efficiently will schedule things on these different threads, which it calls event queues, kind of, or run loops, basically. And it allows it to very efficiently kind of coordinate that, much like async await does, actually, because async await won't be switching threads either, even though it has like actor isolation stuff. Like one actor actually will do something very different. So it's kind of different from what I just said, where one actor may run on very different threads, one after another, and that's because whatever's requesting that work to be done, it's going to try to stay on the thread that's currently on. Just do it in an optimal way where the actor is freed up and stuff like that. So it's kind of the same thing and kind of different. And currently, if you have Swift Neo and you have async await, you have two different thread pools that are being used. But the community decided that is like a negligible. Well, it's not negligible. Like the performance impact is still there, but it's negligible in that the code that you're writing now with like these higher level frameworks like Vapor, where everything has been async awaitified, those benefits are far outweigh the loss in performance that you might have, because it makes coding more robust and easier to deal with. So as a community, the Swift on server like work group basically said, hey, use async await. Don't necessarily use like these futures and these promised things from Swift Neo anymore. Like we plan on getting rid of that with Swift 6. So as we march forward to Swift 6 and get all those guarantees of thread safety along the way, we want you to all use async await, so that way you're ready for that. Like, you instantly get those benefits when we flip the switch, basically. So that's what everyone's kind of marching forwards all together in concert. And they're planning on making Swift 6 the language that will be optimal for this. So until then, we have this kind of duality of worlds. But once we get there, I think it's going to be very, very nice indeed.
Yeah, it's made all the difference in how fast I can write Vapor code, and also how would I say this, like, so much less frustrating, even though, I mean, I've been using Vapor since Vapor 2 and we're on Vapor 4. It's been like 4 years or so. But man, futures are just something that you never really enjoy dealing with. And we talked about this last week with new additions to Swift, where it's better at inferring like result
the return types.
The return types, and like that's a huge thing with Vapor, where you've got all of these, the futures end up, you have this future that's kind of an optional-ish, like you'll get a closure and it'll run when it's available, but it's not guaranteed to be available at that exact time when the code first runs. And so it's just kind of this closure sitting there, and eventually it runs. But if you're returning something through a bunch of these closures that you've kind of, these future closures, Swift is like, I don't know what this is. Let's have you do it, programmer, because you're smart, right? And I'm like, no, just figure it out, please. And it doesn't. So
and you end up with these chains of like 4 or 5 maps on top of each other.
And it's just
dot
nested.
flat map, dot flat map, dot flat map. So you can either have it be a nested pyramid of doom, which is bad, and like the whole community will try to teach you how to not think that way, because you have to change the way you're thinking if you don't want to think that way. Or you have this very nice structure that if you look at it wrong, it will break. Which is because it has to infer what the return type is for each one of those blocks, and that return type becomes the argument type for the next one. So if one thing is off, the whole thing breaks down. And if there's like one ambiguous piece, if one third-party library adds like an overload that you were not expecting, that can mess the whole thing up, because now you have an ambiguity and you have either an as somewhere, or you need to like actually stored in a variable that you can then like add a signature to, and it gets really messy very quickly. And what async await does is it turns it into structured programming, where you just read it top to bottom. You don't care that it's taking breaks in between. It's just regular old code from your point of view, and that makes it so much nicer to write and so much more open to others to start figuring out, right?
Yeah. Oh yeah. Like I've said before, but the barrier to entry is just so much lower for async await, or for Vapor in general, because you're not having to figure out futures. And that's literally, I'm not even joking, at least half the battle of Vapor is just futures and promises. So yeah, good stuff. I'm excited for when we do, get that kind of full circle implementation of async await into Swift 6 and everything. But for now, it's not like the performance is terrible or anything. And for anything that you would likely be doing, especially if it's just like a basic backend database for your own personal app, like you're not going to have any issues. It's not that unperformant for sure.
Mm-hmm. And if you need the performance, you can still use good old futures and promises. Like, they're still there. And they still work, and if you know how to write high performant code, you're probably not going to be deeply impacted by the trivialities of specifying what your return types are. So that shouldn't be too hard to kind of get acclimated to. One last part of like the Swift on server ecosystem that I wanted to bring up is there's a very cool package called Swift Neo SSH. And at first glance, this allows you to write an SSH client in Swift Neo. Now, the cool thing about this that most people don't realize is all SSH is a remote terminal, basically. It allows you to use the terminal application to do something on another computer. Now, generally, this involves giving full access to that other computer, and that's what we're mostly used to when we log in via SSH. You connect to a different computer, and then you have full access to its terminal. Now, as an app, you can do something really cool with this, and you can vend your own terminal to other users. So think of it this way, like you have an iOS app, and you have a bunch of commands that you can run that are like internal debug things, or more advanced features that most users may not care about, but like one or two users, and most importantly you as the developer, could find super handy to have around. You can basically spin up, much like Vapor, where you have like endpoints. You can use Swift Neo SSH to spin up a bunch of commands that can be run from a terminal, and that's just text in and out. It's super simple. Whatever you return back to it gets put into the other person's terminal. Whatever they type, you get as input. This is a great way to have have a direct input into your app that you completely specify. You don't have to worry about all the intricacies there. You basically say, I have this command and I want to give back this response, and you can totally do that. And that, I think, is a really, really cool use case that I didn't necessarily consider when this library was first published. But it is something that it enables, and that is super cool.
So let me see if I kind of understand where you were getting with that. So it's almost like you're sandboxing your terminal in a way to only kind of do what you want it to and not kind of give full permission, basically.
Exactly. So okay. you basically decide what commands exist. They're not necessarily commands that you're used to on a computer. You can say like,
sure.
Oh, in my I don't know. I'm trying to think of a random app. In my podcasting app, I might have commands that record when chapters should start, and record when like mistakes happen, so that way later when I go and edit it, I have all that. Well, you can go ahead and just sign in on the terminal, and now you have access to your podcasting app, whether that's a Mac app or whether that's an iOS app or whether that's a thing on a different computer. It does not matter. You signed into it via IP address. And then from there, there's like special commands that only that app would understand, and it doesn't understand anything else. So you can go ahead and say like, mark chapter, return. Now it's going to mark a chapter. And the coolest thing about this is because it's just SSH based, guess what? It works with everything else. So you can set up on your computer a script where if you press a key, F5, that will go ahead and trigger that SSH connection, send that command and like close it and be done. So you have like full command over anything. Basically, this is like the ultimate plugin experience in Unix land. And that's what I think is like super cool about it.
That's cool.
Like literally anything can like connect to the terminal in some way to do something. And then once you're there, like the world is your oyster, as they say, right? I don't know why they say that, but they do say it.
They do say that. Yeah, interesting to kind of think about and like explore some real use cases, like you're saying. I don't know. It would be fun to just try to implement and see. I don't know. My mind is like thinking about possibilities, and I'm not really coming up with anything concrete, but I can see the potential, I suppose.
Mm-hmm. Yeah, it's definitely not something you would have expected as like a first-party library that Apple just has. But if it became a first-party library that Apple just has, you have to wonder, like, what are they using this for internally? Maybe it's to control their own like server clusters. Who knows? But it's something that's available, and it's something that's really cool. So, yeah, thought I'd share it.
Nice.
So next tentpole that we have, and I don't think either of us have really played with this, but I have kept kept an eye on it because I think it's really, really cool. And this is Swift in the browser. And you might be wondering, well, like, what are you talking about, Swift in the browser? Like, there's HTML, there's CSS, there's JavaScript, but there certainly isn't Swift. And that's where you're wrong, my friend, because you can totally compile Swift not into JavaScript, but WebAssembly. And then that Swift can run in the browser. And you might be like thinking, well, that's great and all, but can't really do much with WebAssembly nowadays. Mm-hmm. You can like calculate things, and that's neat, but not great. And Swift in the browser is not limited to just the WebAssembly part. There's a JavaScript kit library that it comes nearly bundled with. Like, you don't have to include it, but basically you're going to include it every time. And this is a runtime for the Swift to kind of connect into JavaScript so that we can have full access to the DOM. And the DOM is the document object model. It's how JavaScript coordinates with the HTML and CSS. So at this point, you've replaced all the JavaScript, and you can just have Swift, and it's nice and typed, and it's compiled, and it's just a resource that's loaded. And you can take this further, and there's a second library called Tokamak UI. And if you've ever heard of this thing called Swift UI, you might be interested in this because it allows you to write Swift UI-like code to render HTML and CSS live on the page, cool. Just like Swift UI works. So yeah, this is where it all like comes together. And it's not necessarily the most mature thing. Like, it is being used in a very variety of different things, but you do need to download like a custom Swift toolchain and a compiler just for this, because it's not like super mainstream. But I think it is super cool nonetheless.
Yeah, I mean, I've talked about, I'm not like super huge on like web front end stuff. Like, I use Vapor all the time, but it's always for back end stuff, right? But with something like this, I could very much see me making even just like a basic admin interface for a Vapor app or something with this Tokamak UI, because I'm not writing HTML and CSS. It's just basically Swift UI, where I am, again, more comfortable. And that's why, for me, Vapor is so cool. So even extending that further into the realm of, let me, very easily write sort of more front-end centric code is super cool. So I wanted to go back to the JavaScript kit. So let me see if I understand this right. So you were saying that this basically, I mean, it interfaces with JavaScript, but you could basically replace all of the JavaScript logic in your front end. And it's just sort of, that's like the kind of intermediary layer between the HTML and CSS and the Swift code instead, but nothing really JavaScript-y in between. Is that right?
Yeah, so JavaScript includes a little JavaScript. So it is a runtime library that is designed to like run on the JavaScript side to communicate with your Swift side. So that way you don't have to write any of the JavaScript. So that's what's really nice about it. And then the Tokamak UI part will write any necessary JavaScript for event handling, so that way you don't ever have to see any of it. Though you can, like, there's always escape hatches here and there, but you don't have to. And I think that's really cool because it means that in your Vapor app running on the server, you can have this be part of that ecosystem. And with like one or two packages, you have everything all linked up, and you have a full Swift on the server, on the front end in the browser, and on your app that are basically all sharing code that can be shared. Now, it might just be because it's convenient for us who are not necessarily well versed in some of these server programming languages, but it can also be more performant and more efficient, right? Like, Swift can be exceptionally efficient at doing certain things, not necessarily just returning data from endpoints. That's not necessarily its strong suit. But if you need to do high performance computing, it's going to be way better than writing something in Node or Python. So if you need to do that as a part of your server infrastructure, then that is something that's available to you. Similarly, on the web, like, plain old vanilla JavaScript is not necessarily the best way of doing something, and you might want to reach towards something like React that can give you a high-level abstraction that allows you to do a lot more in a more cross-browser way. And Tokamak is basically the replacement for that in Swiftland. And the nice thing about that is it doesn't have 10,000 dependencies. It is something that is much more constrained and something that, as a result, will have a much smaller surface area in the future to be attacked. So if you do want to take a look at these projects, then that can help evolve them further and push them to their full potential. It only comes through usage that you find and fix any issues in a lot of these things, especially these kinds of libraries that are not necessarily made for a single purpose. They're made to be as general purpose as possible. So definitely give these things a try if that's something that you want to look into further, because that can help push the boundaries of what's possible with Swift. And as that gets pushed, more of their work gets merged into the main Swift branch, which means that in the future you won't necessarily need to have a separate Swift compiler just for this. It might just be part of the main Swift compiler. It's just WebAssembly is yet another platform that you can just go ahead and run to.
Yeah, I mean, looking at this year's WWDC, Vapor was explicitly mentioned and I think even used in one of the WWDC sessions. The community has grown it to that point of popularity, I guess, where it's, there's the Swift server work group and there's someone from Apple as a representative in the work group. And it's very much sort of almost a first party supported thing at this point, more or less, which is amazing. So getting these more esoteric things like SwiftWasm and all that supported as well would be super cool. And I mean, for me, as far as Vapor goes, I'm not smart enough really to do anything to contribute to Vapor. I opened one pull request and that's it. And it was for something super simple, just to say that I've done it. And it was, I don't know. Yeah. Anyway, that's all it was, but I'm not regularly contributing, but there are other ways that you can do that. You can support it. You can just use it, which is huge, and start on GitHub and stuff. But you can also sponsor it and pay $5 a month or more and just help those who are dedicating a lot of time and, who are smart enough to work on it to continue to work on it. So there's that as well.
Mm-hmm. And contributing to it involves reporting bugs. That is a contribution. And unlike Apple's infamous bug reporter, you do get responses. Someone's a name that you're going to see right away is Tim, and Tim is one of the lead maintainers, and he's going to be there to make sure that you have a good time using Vapor, because that has become basically his job at this point.
Yeah.
To make sure that Vapor is stewarded in a good direction. So you might be misusing something and there might be an easy solution, or you might be missing something and you submitting that bug may lead to someone else picking it up and fixing it. It is open source software, so there's no guarantees there. Or B, it might lead to someone helping you be able to fix it yourself. And as we've mentioned many times in the past, Vapor is just a package, which means that and all these things, they're just packages. So this means that you can put breakpoints in Vapor's code to see hey, what is Vapor doing with this request that is causing problems for me? And you might be able to solve it that way. Or you might be able to see hey, I just missed one line of code, or Vapor just missed one line of code and it would be able to handle my situation just fine. And there's no need for a huge paradigm shift or anything. So that's something that you can go ahead and submit as a PR. And maybe that breaks a bunch of tests, and there's a bunch of tests, so with confidence that you're not necessarily just introducing code that's going to throw a wrench in everyone else's business. Mm-hmm. So I think that's the nice thing, and when open source software works really, really well is when it is well loved by the community. And that means that one, if there's something that's sincerely broken with the sockets part of Vapor, all in Swift Neo, Apple's engineers are on that. They're going to fix that because they want that to be as robust as possible. And if you found that issue, then it likely impacts other people as well. There are Slack groups that you can directly communicate with all these engineers, whether on the low end on Swift Neo or on the higher end via Discord with Vapor. And everyone is basically willing to help each other. So it's really it's really something that is nice, I think.
Yep. And completely impossible if it was closed source.
Yeah. Like if Swift UI goes wrong, like you have no insight into like what's wrong there. If Tokamak UI goes wrong, like you have breakpoints and you can go ahead and explore that. Though I don't know how that works, like when it's running live in the browser. If there's good debugging support, I would assume there probably is. But yeah. Anyways, this leads to our next tentpole. And that is command line tools. So as we said, like most Vapor apps, they are command line tools. And a command line tool is basically just a program that can take inputs at time of run. And it may like continue running indefinitely like Vapor, or it may do its thing and then stop immediately, like most terminal commands that you're used to. Like if you cd, it will change the directory and then exit out. Right. And although CD may not be like a full executable, it might just be part of the what's that called? The shell that you're using. The shell is a command line tool that you can just switch to a different shell by running one. You can use editors, like you can do all sorts of things in terminal applications in these programs. And command line tools are basically the framework that they all use. Even your apps, like all the apps that we have, they're all technically command line tools, right, but they all interface with something called the Windows server or Springboard in iOS's sense to put stuff on the screen. But like you can run TextEdit from the terminal. You just go to textedit.app/content/macOS/textedit, and it will just start running, and then it will like wait there as if it's accepting input. It doesn't care what you type anymore at that point because it's running its Windows. It has its own run loop. But when you quit it, then that terminal window becomes usable again. So it's all like linked together. This is the most foundational type of program that you can kind of write. But this also means that you can do some pretty cool stuff with it.
Yeah. As an example, what we ran into at work was we were talking about localization at work, and we just send out our localized strings to a service to get them localized into, I think, 10 languages or something for LumaFusion. And the service itself doesn't accept the xcloc files, xcloc files. But it accepts the xlif files that are kind of inside of basically the folder that is an xcloc. So we had a Python script that would, we have the shell script that would take them out of the folder, out of the xcloc, and a Python script that would remove any strings that we didn't want to be localized. There were some that we use like with basically like a hashtag or a pound. I don't actually know like the correct term for that, but anyway, we have a couple strings that we wanted to take out, and so it was this Python script to run through the XML document. The xlif is basically just XML. Run through it and rip out any of those strings so that we don't pay for those to be localized when there's nothing to be localized there. And we sat there at our office on Wednesday trying to figure out why the Python script wouldn't run. And it was because I don't know when this changeover happened, but we're all on Monterey, and the default Python for the terminal is Python 3, not Python 2.7. It happened for both me and my boss on our new, M1 Ultra machines. So that was the issue. We were, trying to look at like syntax errors in the Python script, and my boss is super weirded out because he has used this, very much in the past and stuff. And it was the first time I had looked at it. Anyway, that's a long story to say. We both got frustrated. We figured out it was Python 2.7 that I just needed to install like an hour and a half maybe after running through all of that stuff. And it was a pain. And so we both thought, well, what a better way than to spend more time on something and write it in Swift. So I ended up just taking that, making a command line tool in Swift. And at first I did make it as like a command line interface, like Xcode project, but eventually switched it over to what Dimitri had suggested to me and just made a purely Swift package. I think we're hoping to make it just like an Xcode plugin extension or whatever they're called in Xcode 14. So luckily I didn't need to change any code at all. It just changed how I ran the code from the shell script. But now it's very easily readable and debuggable, and I can put breakpoints in it. And I, just used the XML document class or struct or whatever that is in Foundation and everything, and it was easy to convert over. So I spent a day working on it. But the whole thing to say with this is it's running Swift in just this shell script now by calling the Swift package. But I had a couple structs, and there's this Swift argument parser that's a first-party Swift package from Apple to basically make it really, really easy to make like an entire command line tool that isn't just like CD, like Dimitri said, but when you pull up like you type git or whatever, it says like welcome to git or whatever. Here are the -v for verbose, -h for help or whatever. It makes it very easy. Subcommands, yeah. Makes it very easy to kind of build out that whole like tree of the initial command, then all of these subcommands, writing basically like documentation for all of your commands and everything, and arguments, options, flags. It's got some cool property wrappers so that you say like var input is like your first option, then you have this argument property wrapper, and then you can write a help string that pulls it up, and it's just automatically added to that command line tool. I don't know if I'm doing a good job at explaining it, but basically it made the interfacing with the terminal very easy, where I didn't have to think about formatting text to have it show up when that command is called. It just kind of does that for me. And I really just kind of had to worry about what do I want it to do when the command is called with whatever inputs, outputs that you give it. So super cool to be able to take something that was very frustrating for both me and my boss and wasted a lot of time just with us sitting in our conference room trying to figure out what was going on into something that, I mean, it did take me, a few hours to write it, but now hopefully if there are any other issues, it's very easily debuggable by anyone on the team, because it's just Swift. It's just a Swift package again. So,
yeah. And I want to call out too that it may seem like a waste, quote unquote, waste of time to take something that quote unquote works and then just to rewrite it and something that everyone else understands. But one, you, the developer, tend to learn through that experience. And that becomes invaluable because you can go ahead and repeat those learnings many, many more times later. So it's almost an initial investment that has a very good payoff because it's the first time that you're learning something new, and you can go ahead and explore how that can be beneficial to you going forward, right? So don't necessarily, not you, Spencer, but anyone listening, don't necessarily think that needing to spend like more time fixing something that seemingly has a simple fix, like Python 2.7, might not be something you can install on Ventura or on whatever future Mac OS comes out. Like it may just be closed out to you. So if you do spend time on something like this, then you do like expand what you know, and you can go ahead and use that for all sorts of other things. If you need another script, and you can, instead of reaching for bash and then endlessly not knowing if you have the correct amount of parentheses or squigglies or who knows what, because bash is bash, you can go ahead and just write something that you're comfortable with. And sure, it might not be as succinct as many of these scripting languages, but it can be way more efficient because you know exactly what everything is. Xcode is auto-completing stuff. You have full control over that. And you don't even need to set up like a full package for a lot of these things. Like if it's something that just uses Foundation, you can just write a Swift file. Like, that's literally all you need, and you run it with the Swift like command on the terminal because you have Swift installed, and it will just open and interpret and compile and run that Swift file like in one step, and you will hardly notice if a single Swift file is being compiled because it's not necessarily a whole project that needs to be linked across multiple modules or anything. Like, it's just more or less instant. So if you need to reach for something quick and dirty, Swift is actually not that bad of a choice. And it might have some rough edges still when it comes to like strings and stuff when you want to be fast and loose and you don't really care about any issues. But Xcode will like point out, hey, you have an error on this line, so you don't even have to figure that out later. You can go ahead and deal with it now. And if you build an Xcode, you can like just see it in the output of Xcode, like what your program is doing. So I think that's really neat.
Yep. It was nice that, like, as an example, what I was doing was, not parsing an XML document, but taking a fully created XML document and kind of ripping out things that I didn't care about. And the good part was, because I knew that this was going to be running on just one of our Macs and everything, I could just use I don't know if it's probably in Foundation. Let me see. Just the XML document. Yeah, it's in Foundation. The XML document class. And I didn't need to find some third-party library to do that for me that, would run on the server in Linux or anything. It was just... It's still running on a Mac. It's not in a Mac app per se, right? But it's just running on a Mac. And so you have access to importing any of the Apple, first-party libraries that you would normally have access to. So that was a relief, to say the least. So...
Mm-hmm. And this is especially great if you want to do anything like super complex. Like, you can import AV Foundation if you really want to. Pull in a video file, do processing on it with Core Image, and output it. And all of that can work. And it's something that I've done before. Not necessarily in Swift. Like, I've done this all in Objective-C. But it is like totally possible to do anything you can think of in a regular app, in a command line app. The only difference is you need to make sure that for some things, like if you import AppKit, you need to make sure the Windows server is loaded. You can't just run it like at login screen. It will not be happy. But like that's something easy that you can set up if you want this to run like on command or on a schedule. Like when you set it up with LaunchD, you can set it up to run when you log in. And then from that point forward, like you don't really care. So yeah. Command line tools, really, really cool. Very different way of thinking about like an quote unquote app, but it essentially is still just a program. And as we said before, Vapor, like that's just a command line tool. You start it and it runs until you stop it. And that's like the essence of what a server is at the end of the day. It's just a program that's running on a different computer than your own. And that's not even true all the time. Like you can have a server running on a computer, like a language server, that multiple programs can interact with. That's how VS Code can like show Swift auto completions on a Mac, and that's just because there's a Swift language server for Swift, and that allows different programs, Xcode included, but also VS Code, to show auto completions for Swift as if it were native, because it's all using the same system. So servers, they cool. They're just apps in the end of the day. They're just programs, I meant to say. And you connect to them. And if you want to offer some fancy connections, you got Swift Neo to help you out. And yeah. Swift Neo has your back.
Yeah, I mean, just thinking about everything that we're doing, it's so cool to see, like, I don't know what you call it, like the proliferation of Swift. Just it's growing outside of this. I mean, just looking at like Objective-C, right? There was like the weird like Windows Objective-C thing project that I think someone made way back in the day.
Cocotron
that kind of predates
or something.
Yeah. But like that's it as far as I know. There's not a ton of like, I mean, you could use Objective-C in a script and everything, but like, oh, maybe maybe isn't a great example, because I think there was also like a basically like Vapor with Objective-C, like someone made a web server out of Objective-C, if I remember right. Anyway, my point is there's a lot that you can do with Swift outside of just like the traditional like iOS, macOS, tvOS, watchOS app stuff. And that's what's exciting, is when I want to make a tool, I can reach for Swift and I don't have to worry about like, shoot, if only my language could do this. I really want to stay in my little closed ecosystem, or closed open, I want to stay in my comfort zone, and I can. So that's the cool part, I guess. I don't know.
Yeah, there was a thing called Cocoa HTTP Server, if I remember correctly.
Yeah, that.
And this was built on top of something called Cocoa Async Socket, I think. And this was like the de facto library that was not built by Apple for doing anything socket related, because otherwise there's C, and no one wanted to write sockets in C. So you use this thing called Cocoa Async Socket, and later GCD Async Socket. I think I'm remembering this correctly. I might have all these names wrong in my head, but I use them extensively, and this was basically everyone used these extensively. If you opened any about like Mac apps about window, like you'd see this library being listed because it's like so fundamental to everything, and Apple only provided one like direction of this. You had the NSURL connection, which allows you to connect to an HTTP server. But if you want to do anything else with TCP, like good luck, was basically the message. And you were left like to your own devices to figure that out. So it's very nice that libraries like Cocoa Async Socket inspired things like Swift Neo to provide a higher level access to these very fundamental things that people want to do. And by having a higher level like access point, you can go ahead and now share these implementations across different things. Like Spencer said, like it works on Windows, it works on Linux, it works on Mac OS, it works on Android. And it's something that can work in a variety of different situations and still be the same code that you care about. So you need to deploy to Windows. Well, you might need one or two changes because like file paths are different, but that's about it. If you're not doing anything super complex, or you're not like importing AV Foundation, which won't exist. Like if you're just responding hello to a hello message, and that is something that you can do. If you're doing something more complex, you're interacting with the database. The database is also written in a platform agnostic way, so you can go ahead and use those pretty much everywhere as well. So there's perhaps some potential confusion of like what is part of a platform and what is platform agnostic. But the Swift server working group does a pretty good job of outlining like what can basically work on anything, and anything Apple is directly talking about is generally stuff that only works on Apple's platforms.
Yeah. And there, I'm going to butcher the name. Like Foundation, for example, isn't available on Linux, but you've got like, I think it's Core Foundation or Open Foundation. I think it's Core Foundation. And people are sort of probably, I'd assume, rewriting Foundation, but in an open source way. So you can go on their repo and see like what things have been implemented. Dimitri, I'm sure you know more about that.
So there's Core Foundation, which is a C library. And Core Foundation has alwait's been open sourced. Like this is the part of Cocoa that's always been available because it has ties from way back when. Like before, it's not Objective-C. It's pure C, but object oriented as best as it can be. And this is open source. You can look at the source code for CF Array, which is NSArray. NSArray is just a wrapper around CF Array. And Core Foundation is like that. Foundation, the library, has been re-implemented from Objective-C into Swift, and that re-implementation is completely open source. So things like XML document might not be available. But they are declared because they're technically part of Foundation, and people are free to fill in the stub methods. And generally what this involves is calling the corresponding core foundation counterparts, because everything in foundation is part of core foundation. And that is how you can link everything up. So yeah, everything that's in foundation is available like via core foundation. And I would say by this point, everything has been implemented in foundation that you would need. There are some things that are still lacking, like URL sessions new async await abilities. For some reason have not landed in the Swift version of foundation. And this is important because on Linux, that means you can't use async await with URL session. That said, when you're doing Swift on server stuff, generally you don't want to be using URL session. You're going to use async HTTP socket. Async HTTP client, I think it's called. And this allows you to do like the opposite of what a server would do. As a client, you can connect to an HTTP server and do something.
Right.
And the key piece here is it uses Swift Neo. Like that was the only reason it exists, because this means you don't have to hop between threads. You can continue to use the same thread pool that Swift Neo sets up. And just as you receive a request from another client, you can make a request to another server, and that's all going to be coordinated for you. You just need to say like, hey, next I want to do this. When this comes back, next I want to do this. When that comes back, next I want to do this. So you can coordinate a bunch of different things all happening simultaneously really easily because it's all built on Swift Neo. And that's probably why like some things haven't made it to the Swift Foundation yet. And this leads us to our very last tentpole of the day. And this is the one that we kind of alluded to at the beginning when Apple said that Swift is running on the Secure Enclave, which is a coprocessor. This is something called an embedded device. So embedded devices generally do not have an OS. There's no like operating system and kernel that is managing anything. Like your program is the OS. You have a starting address, and whatever's at the starting address will be what is run as like executable code, and you manage pretty much everything else in the way you want to manage it. Now, generally, things are a lot more powerful and a lot more complicated than they used to be back in the day. Like, it's not something along the lines of you have a few kilobytes of executable like memory. You have a lot more nowadays, but it's still limited, generally around 4 megabytes of ROM. So it was traditionally a little hard to get Swift into that environment, because Swift, once you compile it, your hello world can turn into something quite large, because not only does it need to have your executable code for hello world, it needs to have the executable code for the Swift runtime and all the libraries that are all part of that ecosystem. And on macOS, that's a shared library. Like all programs are going to be using it, but on an embedded system, heck, you're the only user of it, and therefore you need to load it up regardless. So that can be a problem for Swift. And something that has been done in the past year that has made this whole process a lot easier is the Unicode library that Swift was relying on to provide Unicode support has been rewritten, I believe, was mentioned in Swift. And what this means is that it can be selectively included when you need it. And if you are not using complex Swift string processing, you can leave it out. And if nothing you import uses complex Swift processing, then it's not an issue that you ever need to deal with. So this has been split up as a part of the regex work that Apple was doing. So curse you regex, but thank you regex. And it is something that enables this brand new environment to be possible, which is running Swift in a much more constrained environment, but because it is Swift, because it is a compiled language, because it can go ahead and take shortcuts and simplify things, and you can have generic code that has structs as like the most optimal way of accessing data. Like you can get some very high performance if you know how to play your cards right if you will. So it's not necessarily like automatic super high performance. You still need to work for it, but it's high performance that might be a little easier to achieve than needing to like wrangle C++ and its multitude of features, for instance.
Right. I remember it was back in like, I can't remember when it started, but there was this Swift for Arduino thing going on that maybe is sort of the precursor to this. Let's see.
Mm-hmm.
There's
Yeah, so that was the first few attempts at something like this, and they basically needed to rip everything out of Swift and then like bring in just what they needed for Hello World, and then they tried something more complex and just bring in that and kind of like repatchwork it together to get it to work. So it's not at all ideal for anything, but seeing as Apple's now using this internally, like the key dream, right, of Swift was from the app to the silicon, like it's something that you can run at any level, is finally starting to precipitate, and I think that's pretty cool.
Yeah, exactly. So like it was a ton of work. It looks like they're actually still updating it, which is super cool. But yeah, I mean, it was no doubt a ton of work just to get it running on an Arduino. But now that there's this Swift embedded library, it's no doubt much easier. Of course, you've got the limitations, and like Dimitri said, having the entire toolchain on something that has like 4 megabytes of storage could potentially not leave you a ton of space. But like their example in the repo says, a Hello World application has a little bit over 1 megabyte because it includes a big part of the Swift standard library. However, it's a fixed cost, and you can fit quite a lot on a microcontroller with 2 megabytes of flash, because then basically that extra megabyte is just your own code, and that's a lot of code that you could write.
It's a million more bytes, right?
Yeah. So you can, go from there and say, all right, well, now there's something that is you could fit a lot more, and also no doubt it's a lot easier to get it just working on a board in general. So be interesting to see like the specs of what the secure enclave is. I'm sure it's more powerful than that, but it's probably not huge either.
Mm-hmm. No, I would imagine it has a very small like amount of flash that's available to it that it runs from. It probably has a very low what's it called? The cycle speed, like
clock speed.
Clock speed. It probably has a very low clock speed. It's not necessarily doing heavy lifting. Its sole purpose is to like cryptographically sign things, which it probably has special instructions for that are like suited to it. Like you tell it, hey, here's some data. Here's some data that represents a key. Please sign this, or please verify this signature. And it can go ahead and do that probably very, very well. But it's probably not capable of doing much else in a reasonable amount of time. So that would be my guess.
Yeah, that makes sense. I was going to ask you, it sounds like you know way more than I do about this Swift embedded. So like, if you ever work with like a Raspberry Pi or an Arduino, you're always dealing with like GPIO pins, right? And like having things happen when things happen to those pins and everything, right? Mm-hmm. Is there like functionality to like interact with IO pins on these boards? Is that like a part of this kind of specific tool chain? Do you know?
So the Swift embedded library that I'm going to link in the show notes was a previous attempt at this. It's not really a library; it's just an example of doing this. It's the tool chain more than anything else. So I wouldn't say that there's any like library to access the pins. There's like nothing high level. However, when you spend any amount of time doing this, of which I have spent like almost none, but I've spent a ton of equivalent time in YouTube, I'd like to pat myself on the back with, which amounts to nothing. But I have spent a significant part of my life at this point, like learning about stuff like this and being very curious about it. And it seems like the way that these pins work is they're just a location in memory that you can read or write. and that's basically it. The way most of these systems work, and especially when you scale them up to a computer, is you have regions of memory that are part of a bus, and that bus can either like link those regions of memory to actual chips of memory, or they can link them to something completely different, like a display, or input output, controller pins. Like you can think of basically anything, and that region of memory just becomes available and wired up. And it might not be memory, but you can still write to it, and you can still read from it. So when you write to it, if you put zeros and ones on a byte and you say this is available at this address, and then you tell a separate byte like, hey, load from that address, that might be you signaling to the display driver, hey, this is data that you want to consume. And then you do that enough times, and the display driver is like, hey, I have enough data to put some letters on my segmented display. Right, okay. And that's how that all like hooks together. So individual pins, those are just bits at the end of the day. And you choose, like, I want to set these bits to this or that. And once you set them, they're quote unquote set, based on whatever like shift register is connected up to it to keep that value alive. Because the CPU is only doing one thing at a time. It's setting this memory and then changing the address and then setting that to something else. So the CPU is just so like,
there's like,
go for it.
Sorry. There's like, I mean, I guess you'd have to have documentation on like the specific microcontroller you're using, but there's really no reason that this couldn't do it, basically.
Exactly. So the tool chain that you use is very tailored towards the microcontroller that you're using, right? Because it needs to know like what assembly it understands. It's not like magic that Swift is just gonna like be compatible with it. If you have a microcontroller that has different assembly, it's not like based on ARM, for instance, it's based on something novel that you made up, you have to write a compiler. Like that's right. At the end of the day, that's what you need to do. However, you only need to write the output compiler because LLVM is something that is fully extensible. Like the Swift front end is separate from your compiler that will assemblify the IR, the intermediate representation, into assembly. So at that point, it can be Swift, it can be C, it can be C++, it can be JavaScript. It doesn't really matter what that input is. You can turn it into whatever you need to turn it into. So this is where all this kind of fits in is I imagine soon it will be much easier to kind of use the Swift front end with any backend that you want and not necessarily end up with a huge binary at the end of the day. Because it's not something that necessarily needs to be included. Like for in order to print Hello World, you need a lot. You need an output, right? And an output is not for granted. As I just said, it might be special pins that go to a display. And that might be something that is very unique to your hardware setup that you're currently dealing with. It might just be a sequence of bytes that is just transmitted over a literal wire to something else. That is a very different scenario as well. So print Hello World is not as simple as you might think, but one like var A equals 1, var B equals 2, and then memory address equals A plus B, that is a little easier. And that's generally what you're kind of starting from when you're doing this embedded stuff, because you're just shifting data around at the end of the day. You're moving stuff from this memory address to that memory address. And a lot of times it's pretty easy to do that with assembly, like even. But it's something that you need to learn. It's like you don't have if statements. Sorry. So it's a little hard to deal with. And once you get into structured programming, you have a bit more control. But at the end of the day, you also lose some control because Swift is like stubborn when it comes to accessing memory. So there are some difficulties there, but you can write abstractions, and once you write those abstractions, then it becomes way nicer to use. So if you have an abstraction for your particular little camera module or your particular little display module that works the way it works, like you move to this memory address and you give it this data, and that will trigger something. and you do that sequence enough times, then it has enough data to display whatever message you want to display. That can just be a function or a class or a struct or whatever you want. And then you just have to call it and say like, hey, I want to show this data, print screen, you might want to call it, and that will just work. So that's what this comes down to at the end of the day, is you need to do a lot of low-level stuff because you're working at the lowest level possible. No OS. Your code is the code. But you can also do high-level stuff once you've written an abstraction layer on top of the low-level stuff. And that's what you do with assembly, too. It's not like you're going to, every time you need to print something to your little display controller, you're going to go ahead and switch a bunch of pins and do that manually. No, you're going to call a subroutine because you don't want to ever deal with that ever again. So you call your subroutine and say, hey, the data is at this register. And that register points to null terminated sequence of memory. So deal with it. That's what you would write. Yeah, that makes it a ton easier to do all sorts of stuff. And I would assume that's what Arduino ends up being. You have some high level, I think, Python code for the most part, right?
I think it's C.
Is it C?
I don't know.
Yeah, it shows you how little we know about all this. Yeah. But it's something that at that point you don't necessarily need to deal with the display controller or the camera module.
You're just importing a library.
Or the LEDs on the pins. You just import LED library, and that allows you to interact with pins. You just need to say, oh, this LED is at this pin, this LED is at that pin. I want to turn them on and off, please. And you are able to do that. So this week's episode of Code Completion is once again brought to you by Bon Voyage. Bon Voyage is a full-stack iOS application development course from Johnny B. With this course, you'll learn how to build both a full iOS client app and an associated React web administration application. The app and the site will integrate with Firebase, as well as Stripe and Plaid for payment processing. Bon Voyage is a place to book extravagant vacations, and you'll gain the skills to build the iOS app from the ground up and integrate everything you need to provide a world-class vacation booking experience. You'll find out more and sign up for the course. So to do so, visit bonvoyage.app/course. That's bon-voyage.app/course. And be sure to follow Bon Voyage's instructor, Johnny B. Codes, that's at JONNYBCODES on Twitter, to stay up to date with all his courses. Thanks again to the Bon Voyage e-commerce app course for sponsoring Code Completion. As always, I want to personally thank everyone for listening in this week. Please be sure to follow us on Twitter at Code Completion to know when new episodes get released, and feel free to tweet at us if there's ever a topic you'd like for us to dig into. Most importantly, as a small podcast, please be sure to share this with your friends and family who are also interested in any part of the process of app development. It's your support that enables us to continue doing this, and we hope to grow a healthy community around everything we discuss. Once again, I want to give my thanks to Spencer, who is at Spencer C. Curtis. That's SpencerCurtis on Twitter, for joining me this week. My name once again is Dimitri. You can find me at Dimitri Buniol. That's DIMITRIBOUNIOL. And we'll see you all next week.
Bye.
Okay. I have a little mini, but hopefully not too many, but mini topic I wanted to get into. Yes. And that is Awesome Games Done Quick. And they had a very interesting reveal midway through they usually call these sessions a
showcases.
A showcase, yeah, a glitch showcase. And these are really cool because you get to see all sorts of wacky things that can be exploited inside of a game that you know and love. And this one was a glitch showcase of Ocarina of Time. And basically, 2/3 of the way, and they reveal this is not actually a glitch showcase. This is actually a new category that we're calling Triforce %. And you might be wondering, what's Triforce %? And when Ocarina of Time was first unveiled, and I'm not talking about release, I'm talking about just unveiled. These are demo scenes that they showed off at something called Space World, which is not a thing anymore. So when that was first revealed, they showed a bunch of things that no one ever has seen in the game, like a unicorn fountain, and Link achieving and attaining the Triforce. And this was more like just demo material. Like they need to put something on screen, and they don't.
Yeah.
They have a game engine. They don't have a game. So they're like, let's just throw something together. And perhaps some of these ideas were like meant for the final game, because on the first version of the cartridge, there are a bunch of demo assets that were like vestigial left over. And if you know anything about like ancient game consoles, space is limited. Like you don't just leave this stuff around. Much like the embedded system, like you have megabytes to work with, not gigabytes. You have like single digit megabytes at maximum to work with for your entire 3D game, which is like mind blowing. So you don't have very much room to just leave around for these big graphics that you're never going to use. And yet they were still there. So that makes you think that they were potentially being considered quite late into the development cycle, and there potentially were aspects that were reusing them. This glitch showcase showed off a lot of those. And what they did is they did something very interesting, and they built up the missing pieces from everything that we know. It's all speculation, really. But they were able to build up these missing pieces and put together a storyline that leads Link to attain the Triforce. And you might be wondering, well, that's cool. Like, they just modified a cartridge to kind of get this going. There's been a lot of work on decompiling Ocarina of Time and getting it to the point where you can basically do whatever you want in the game. You just gotta rebuild a ROM and put her in, have a modified system, and it's just an emulator. You can do whatever you want, right? Easy peasy.
Yeah.
Except, and this
they
is
did
like
not.
They did not. So you have an
cool.
unmodified N64. The only modification was, instead of like a coaxial out or whatever they had back in those days. I'm just kidding. It's the yellow, white, and red video component, I think it's called. I don't know. It's been a long time. I'm not sure if my TV even has that anymore. Actually, I had a TV that did not have it, and my newer TV does have it, which is weird. But yeah, I can technically plug in a Nintendo 64 on a 4K television, and it'll look like
nice
absolute garbage as a result. But they did modify that to have a clean RGB signal. So this is still what the system is outputting. It just does not get converted into an analog signal. So pure digital signal out. That's the only like difference from the game's point of view. It's none the wiser. And the cartridge is an original unmodified like cartridge. Now, something that has become possible with Ocarina of Time in the past few years is something called arbitrary code execution, or ACE. And this allows prospective players to mess with the game and do shenanigans that they definitely should not be doing, like writing their own code. And this allows them to like flip bits, like fast forward to the end of the game, and that's how any percent is currently done. You do a whole bunch of wacky stuff in the Kokiri Forest, and then bam, you're at the end of the game. And none of it makes sense. It might have crashed like if you did one slight thing a little bit wrong because you set up memory addresses wrong. But long story short, they started off doing this, and they did something very interesting. Instead of warping to the end of the game, they basically moved the instruction pointer, like that the game runs automatically, from whatever it needs to run in the game to the controller inputs. And the controller inputs were connected to something called TaskBot, which is like a little Rob, guy that someone connected up to a computer, and it basically just over USB will flip the pins on the controllers as if you're pressing buttons really, really fast and in a very accurate way. So this is not necessarily meant to be done by a human, though it has been done by humans, like not necessarily in Ocarina of Time, but like crazy things like reprogramming Super Mario World to become Flappy Bird has been done by a human, like live on stage, and it's mind-blowing. But this is on like a slower system where you can actually like keep up pressing buttons really fast and in a very accurate way. This is a bit like out of the realm of humanity, but it is possible. Like you can imagine a robot on top of a controller pressing button like really quickly. That's essentially the same thing, and that's kind of the the nuance that they wanted to like make very obvious. They are not connecting the system in any way. They're not using any pins that are not available on a controller. It's just controller input. They're not using the little memory pack that you can connect into. Like they could do whatever they want if those were the limitations. But no, they said just button input. They set up not one, not two, not three, but 4 bootloaders that will like call the next one incrementally. So the first one basically just speeds things up from like 1 byte per frame to 2 bytes per frame, and then from 2 bytes per frame to 4, and from 4 to 64, to the point where you can actually like get actual data into the N64. And they progressively like do this one after another, and Link like fidgets a little bit, and then it's quote unquote done. And all the player needs to do at this point, like there is someone still controlling the game at this during this whole point in time, which is like pretty crazy. Like they created the input. The taskbot did not like get a remote code execution working. It was a human that did that, and then the human just said, "Hey, taskbot, can you press buttons for me really
Take
quickly
over
on the other controller ports?" So at this point, they take over and they like go in and out of the forest, and then all of a sudden they have a debug menu that's part of the game that's just like turned off, available to them, and you can flip some inventory. And then they start playing through, and they start like addressing all sorts of interesting things, like the fact that you can power up masks, or the fact that you actually can beat the Running Man, and you can actually like fight him as a boss. Like there were a bunch of weird ideas and wacky ideas that were like part of this game, animations left intact, that were just never used. And rumors that started as a result, like, oh, how can you ever beat the Running Man? Well, maybe you can change from adult to child and from child to adult without visiting the Temple of Time, and that allows you to cheat. And by cheating, that allows you to get certain aspects of the Triforce. And of course, they made up the time, like the narration along the way. Like they needed to patch in stuff that just did not exist. But based on things that they knew, based on things that were found on development carts from like the Space World demo, they were able to inject this code live on stage to an unmodified system in memory, that completely changed how the game works. So this is like the portion of GCD where they like turn it into a tech talk, that talks about like how like what they're doing. And it gets to the point where they are live injecting, like at the very end of the video. I don't want to spoil all of it, but at the very end of the video, they are live injecting the comments from like the community on Twitch live.
Yeah.
Like that's the point that they
cool.
get. So it's completely wackadoodle. But yeah, so amazing. So just wanted to call out that.
Yeah. Definitely go watch it. I was watching a video on kind of, sort of talking about it. I need to watch the just like straight up run. But I watched the video of like how it was done and I want to say, and I could definitely be getting this wrong, but for all of the code that was written from the taskbot, it was something like 2 million inputs or instructions or something. Like it was a ton of information that was written in order to, create the storyline. And it shows them, like they made their own assets and everything. And that had to be injected into the cartridge through this taskbot and everything. And just absolutely insane. Like we talked about this before. The dedication of speedrunners is insane, and people reverse engineering the entire game, but then taking it further and like thinking about, oh, how can we get to the end of the game as like the end game of arbitrary code execution to let's create an entire like quest line, is incredible. It's so cool. I think Dimitri and I are probably the two out of like all of the code completionists that like love Ocarina of Time the most. Like it's very much like the game of my childhood, that and like Mario 64. So to see this like to see people speed run the game just in general still is super cool. And it's always nostalgic. I mean, the music's great, the game itself is great. It's like I kind of have like the I don't know what they call it, but just like my perception of the game is just like it's like perfect, even though like the graphics, like that's like the one game where it's like I don't think the graphics haven't aged well. Like I think it still looks really good. I don't know. It's kind of weird.
I mean, they
like,
had shadows. That's the thing is, as long as you have shadows, they don't need to be the best shadows. They don't need to be accurate. They're just gradients in one direction for 2 feet. Like it's not a shadow, but it's a shadow. Like that's all you needed to trick your brain into be like, oh, this is a real light. There's an environment that you're interacting with, and Link's face is small enough they don't notice how jank it looks. And that's just the way it is, right? Like.
Yeah,
it's perfect.
It's like rose-colored glasses, but it's so cool. And to see people like, man, you got to watch the end of the thing. It's just, like really cool, kind of like callback. 23 years later, like we're still in this. There's still the story going on, and being able to inject like comment, like Twitch live chat, basically into the game is like, oh my gosh, so super cool. I don't know, man. It's people's dedication is cool.
And once again, I don't want to spoil it, but the Nintendo 64 is capable of some interesting graphical abilities.
Yeah.
So it's not as ancient as you might think, with 23 years of chops on our shoulders to fully optimize it. So I think go for it.
Sorry, I was just gonna say, I think we talked about this before, but was it the Nintendo 64 that was like the console that like C was just like a brand new thing, and like they were still figuring out a lot of stuff? Was what was that video? I think we mentioned it. It was super good though, but just like it wasn't optimized. None of the stuff was optimized because it was such a new language.
They had no idea what they were doing. So like they made that game knowing no idea what they're doing. Basically like inventing architectures along the way, like we love to do. If you feel bad and you're like, Swift is grumble this and Swift UI is grumble that, like this is just programming. Like we as developers and programmers have been doing this, it seems like, since the beginning of programming. There's always something new. There's always inadequacies with it, and you work around it. And then 3 years down the line, you realize, hey, that first version of Swift UI, you can do some pretty crazy stuff with it. We just didn't really know. You can move on to Swift UI 4, which is new and shiny, or you can like stick around with the old one and still provide these really cool experiences. So it's something that you need to like build up experience with. And after many decades at this point of having Nintendo 64 hardware, it seems like people have started figuring out cool stuff that they can do with it that was not previously possible. I mean, once again, this is not using any expansion ports. Like, it uses the RAM expansion, the expansion pack.
Sure.
I didn't know that was a RAM expansion. I just knew that some games needed it, and I was like, okay, buying this thing, I guess. Or, oh, please, can you buy me this thing? More like it. And that just goes on top of the Nintendo 64, and then that is what is necessary for all this to work, because that's where all the code is being uploaded into. That's the extra RAM that is being used. So the craziest part of all this is a human can do this. Like, most of what the taskbot was doing was to make it possible to see this in a live setting, right?
Yeah.
You can push 2 million inputs one by one if you wanted to, and you can have the thing read once per second. So you do one input, and then you do another input, and then you do another input over like 4 controllers. Like, you could totally do this as a human, or perhaps with a friend. But you could totally do this one by one, and if no one messes up, you can end up with the same exact result. But like, just have a little robot do it for you. It's not necessarily very different at the end of the day, and that is the coolest part of this technical demo, because that's what it is at the end of the day. A tool-assisted speedrun, that's what a TAS is you have a tool that's doing what a human could potentially hypothetically do, but is pretty darn hard. So we have something demo it along, so that way we can see the possibility for this. And some games have like reached that point where like the tool assisted thing is what humans can do, and there's nothing better. Like I think the original Super Mario is like one of those examples where you have to reach like frame boundaries anyways, so it's like there's no point speeding up and getting a little faster because it's still gonna like be the same time. But for other things like this, it shows us like what could potentially be possible, and I think that's really, really cool.
Yep.
So I will have links to both the actual run, which has finally come out, and the explanations. They have released so this was like a very coordinated attempt on this team, because a lot of people were involved, so they didn't want their like hard work to go unnoticed, and they well deserved that. Like the copyright at the end of this is their team and then Nintendo. Like they did a significant amount of work for this particular demo. So they did a coordinated effort to get a whole bunch of Zelda YouTubers like all working on this like together to showcase how this is possible and what work went into it. Like basically within a week or two of arbitrary code execution being possible, like people started thinking of this project. So
it's been like years in the making.
Oh yes, it's not like
It's
instant
insane.
overnight that this is possible. If you thought like hackers getting into your phone was bad, this is like hackers getting in and rewriting your house. And you're like, how did you get in my house from my phone? That's basically the analogy that's going on here. There's a lot of effort. We'll post the video to the actual run, which you should definitely run first, and then I'll post a video of my favorite exploration of it that really explains like what's going on. How can a controller input do any of this stuff anyways? Spoiler alert, it's a memory address. That's all it is at the end of the day. You tell the CPU, hey, read from this memory address, and that's where the controller is. So it's just magic.
Like it's GPIO pins or something? That's crazy.
You press a button, that bit is on. That's a circuit was established. Ancient stuff at work. I guess there weren't that many pins on the Nintendo 64 like port, so
there's like 3.
It's like there's the 4 and then 5. I don't know. They had some way of communicating a byte through that, and that's what you get. I think it was like 6 bytes for like each controller. And then that does not include the expansion thing, which has a lot of pins. So I'm sure it's like some serial port of some sort. Probably one for like a pair for the controller, a pair for the IO on the controller board. But yeah, anyways, long story short, this is an embedded system at the end of the day. Maybe you can run Swift on an N64 one day. Who knows?
Oh my gosh.
You'll be able to just run your Hello World because you'll fill it up with the standard library.
Yeah. I just looked it up. The of course it's in like 16 megabyte increments, but the Ocarina of Time entire ROM is like it's like 26 megabytes on a 32 megabyte cartridge. That's it. That's the entire game, dude. That's crazy.
Yeah, and there's a lot to that. It's not like sure any percents they like go fast, but 100% that still takes hours even today to like fully complete. There's a lot of stuff in the game, and sure a lot of it is assets, but a lot of it is code as well, right? And like code is surprisingly large when you don't think about it, especially when you want to make an app clip of something and you can't make an app clip because it's bigger than 10 megabytes. That's all your
They've
code.
got an entire physics engine in there, man.
Yeah,
that's crazy.
Link's hat used to be all wavy and physicsy. I guess it was distracting. I don't know. Maybe it caused crashes or something. Who knows? But yeah. So definitely check this out. I think there is a special ROM available that like the TaskBot did all its stuff to already, so you can actually play their particular demo without having a TaskBot like do it for you. However, it's like super finicky. It does not necessarily work very well in emulators. It's made for the demo that was done, and only that. So like don't go expecting it's not going to crash on you, because it is a heavily modded version of the game that has like a very clear purpose in mind. But it is super, super cool. So definitely check it out.
Yep.
Okay, that's all I have.
Okay. All right. See ya.
Bye, everyone.